integral too. Okay, last time we introduced definite integral with Riemann sum. So we're going to do the concrete example of the integral. Okay, compute definite integral from 0 to 2 x squared minus 2x dx. Okay, using the Riemann sum. Okay, so first we have to do is we need to divide the interval. Interval is from 0 to 2. 0, 2. So we divide this one equally. Okay. X sub 1, x sub 2, x sub n minus 1, 2 equal x sub n. 0 equal x naught. Okay. So delta, first we want to know delta x sub I, which is now it's because it's equal division, because of the equal division, delta x is equal 2 minus 0 divided by n, which is 2 over n. Good. Okay, so therefore delta x equal 2 over n. Okay, that's first step here. Okay, and next, okay, we have to find choose points, evaluation points. Okay, evaluation points from each interval, sub-interval. Okay, evaluation point like this. But we can choose evaluation point as the end point. So we say the evaluation points, CI is, we can say xi, which is I equal 1 to n. Okay. Now each xi we can describe x sub I. Okay. So we can describe x sub I using the interval, delta x. X sub I is 0 plus initial point plus because it's end point, so delta x here, delta x and delta x. So we can count x sub I using delta x. So therefore x sub I is 0 plus delta x times I. So 2 over ni. Okay. So x sub I equal 2 over ni. This is the okay, now we get second step. Okay, then we can make the Riemann sum R sub n, which is sigma I varies from 1 to n, I varies from 1 to n. We substitute x sub I to the function, so 2 over n I square minus 2 times 2 over ni and times delta x, which is 2 over n. okay, is equal sigma I varies from I to n, okay, 4 over n squared I squared minus 4 over n I times 2 over n. Okay, is equal we distribute sigma to each term, so 4 times 2 8 over n cubed sigma I varies from 1 to n I squared minus 4 times 2 8 n squared sigma I varies from 1 to n I. Okay, so we know the formula of this sigma I squared and sigma I both. Okay, we apply the formula then for each term, so we get is equal 8 over n cubed n times n plus 1 and 2n plus 1 over 6 minus, okay, 8 over n squared n times n plus 1 over 2. Okay. Now this is the Riemann sum. Okay. Now we take limit to find a definite integral. Take limit. N goes to the infinity. Sub n is, okay. Now we look at this Riemann sum here. The numerator has degree 3 term, n cubed, 2n cubed, and n cubed in the denominator here, so we can cancel here. Therefore, 8 times 2. The numerator has 8 times 2 over 6 minus here. Numerator, second term, numerator has degree 2 term, and degree 2 term in the denominator again. So we can cancel. So minus 8 over 2. Okay. Which is 16 minus 24 over 6, which is minus 4 over 3. Then we get this result. So the integral is now minus 4 over 3. Okay. Why it's minus? Because when we look at this graph, okay, look at this graph. This is a graph of y equal x squared minus 2x. Okay. Then the interval is 0 to 2. So the graph is below the x-axis. Therefore, the integral calculate this part. Okay, negative values. So therefore, the result is negative. Okay, so we apply the Riemann sum to calculate a concrete definite integral. Okay. Okay, thank you for watching. See you next time.